Marija Lukić and I am assistant and PhD student here on the Faculty of Chemical Engineering and Technology. And I wanted to introduce you with my two colleagues.
I'm Dorotea Marčec, I'm a Bachelor student.
And I am Marko, a Master student.
The reason why we are gathered here is because we want to introduce audiences with our faculty. Next year, in 2019, we will celebrate 100th anniversary of our existence. The main reason we chose to conduct organic synthesis in milireactor is this professor, Professor Vladimir Prelog, who was a Nobel Prize winner, who was a professor here in this classroom.
One of the main disadvantages of using microreactor devices is clogging of reactor if you want to conduct reactions such as crystallization. That is the main reason why our reactor is 3 mm in diameter. To ensure the effective mixing of reactants, but also higher volume to surface ratio, prismatic static mixers are put inside of the channel. 3D model was made in SketchUp and turned into STL file. It is possible to put STL file in other type of 3D printer for using additive technology called stereolithography. We used fused filament fabrication and Ultimaker 3D printer. STL file was turned into G-code with slicer Cura. Main criteria for choosing filament was chemical resistance on reactants. Most commonly used materials for fused filament fabrication are PLA and ABS, which are not stable in acetone. So we chose PATG.
In this demonstration, we are doing synthesis of dibenzyl acetone, which was used in sunscreens, because its absorbance maximum wavelength is in UV spectrum at 331 nanometers. Today it is used in organometallic chemistry as ligand. This reaction is base catalyzed aldol condensation, and reactants are non-toxic, safe to use, which is in accordance to green chemistry. Required reactants for first syringe are benzaldehyde, ethanol and acetone. Another one is loaded with 10% solution of sodium hydroxide. Final product is pale yellow emulsion of dibenzyl acetone, which was cooled in ice bath to get crystals. This reaction is often used in students' organic chemistry laboratories to demonstrate aldol condensation. So it is important to say that the traditional way of synthesis includes vigorous shaking and more longer time to produce final pale yellow crystals.